Let's see some more numericals on this TLB hit rate. So the data is given like this. TLB access time. TLB means TLB access time. In order to access the TLB, the time taken is given like this, 20 nanoseconds, so on. And then memory, MM is memory access time. So in order to access the memory directly, the time taken is 100 nanoseconds. That is what is given. And then TLB hit rate. TLB hit rate means out of 100% of out of 100 references, how many references are resulting in TLB hit, which means how many page table entries that you are searching for are directly present in TLB and how many are not present. So hit rate means how many are present in the TLB, and what is the miss rate? 1 minus that, isn't it? And now page table levels. Okay, so this is a parameter which will also affect the effective memory access time. The reason is, if I have more page table levels, in case if the entry is not present in TLB, then I might have to access the main memory for many times in order to get that required page table entry. And then finally they are asking various things. So one kind of question possible is, the entire data will be given and then they will ask you what is the effective memory access time. That is one kind of question possible. And the other kind of question possible is, they will even give you the effective memory access time, and then you are supposed to guess, or you are supposed to say what should be the TLB hit rate, so that you will not get you will get such a kind of effective hit rate, right? And the next kind of question is, they will give you everything and then they will ask you what should be the TLB access time, so that the effective access time is going to be that. And the other kind of question is, they will give you everything and then they will ask you what should be the main memory access time, so that the effective memory access time is so and so. So all these questions are possible. Let's solve this. It is very straightforward. I am not going to do the numericals for you, the math part. You do it. I'll just explain you how to solve it. So the first question is saying that TLB access time is so and so, memory access time is so and so, and TLB hit rate is so and so, and the number of page levels are 1. Then what is the effective memory access time? So watch it. So how can you solve it? So 80% of the time, so 0.8, the whatever you are looking for is already present in the main memory. So that is why in TLB, that is why it is 20 nanoseconds plus once you get the page table entry, we are even supposed to get the required word from the main memory. Always the required word will be present in the main memory, unless we use the caching, and that is again a headache. So generally we go into the directly go into the main memory and get it. Okay, so caching we can use it, but that is again introduce it. It is going to be a headache. So for now, just keep it simple. And next thing is, assume that there are no page faults. So once we get page faults also into picture, every problem is going to be very complicated. We shall do that, but right now we focus on this. Okay. Now how much is this? 20 plus 100 plus 0.2. This is miss. So whenever there is a miss, then what we do? We have to find out that it is a miss, and then we have to go and get the page table, and then we have to finally access the main memory, right, for the word. So this is the effective memory access time, right? So if you solve it, you are going to get 140 nanoseconds. 140 nanoseconds is the answer for the first one, right? And what about the second one? They are saying that everything is same as first one, but only thing is the number of levels in the page table is 2, which means in order to get the page table entry, we are supposed to access the main memory 2 times. So where will the difference be? So whenever it is present in the TLB, there is no way we are going to search the page tables. Therefore, if it is present in TLB, just search the TLB and then go to the word, go to the main memory and get the word. That's it. If it is not present in TLB, it is where the difference is. You have to find out that it is not present in TLB first thing, and then you have to go into the levels of the page table and then get the particular required page table entry. Got it? And there are no page faults, which means all the pages are present. Then how much is it going to be? So here I am going to write it as 2. 2 means in 2 level page table, right? So 1 level page table is here, and the second level page table is here, and finally the main memory is here, right? So first I have to get this, and then get this, and finally get this, right? Therefore, this part is going to be this part. So 2 times I have to access the main memory in order to get the page table entry. right? So how much is it going to be? If you solve it, it is going to be 160 nanoseconds. I think so. Yeah, 160 nanoseconds. Okay. And now for the third one, everything is same, and they are saying that the number of levels in the page table are 3. So instead of 2 here, I'm going to put 3 into 100, right? So then what happens, whenever there is a miss, this entire is the page table. Now I have to access the main memory 3 times, and then finally the required process, right? So how much is it going to be? 180 nanoseconds. Okay. And the next one is 20 nanoseconds is the TLB access time. Everything is given, and then they have given us even the the effective memory access time. Then they are asking us what should be the hit rate. So how can you solve it? So let us assume that the hit rate is P. Then we can start from there, right? If the TLB hit rate is P, then what is the effective memory access time? So effective memory access time is 130, which is already given, and number of levels are 1. Good. So if the TLB access hit rate is P, right, then what happens if it is a hit? If it is a hit, then the time taken is 20 nanoseconds plus 100 nanoseconds. And if it is a miss, right, then what happens? We are supposed to find out that it is a miss, and then we have to go and search in the main memory for the page table, and then we have to get it to the word and get it, right? So this is the entire parameters. Now you could solve this equation in order to find out the value of P. So if you find out the value of P, you get 90%. Okay, one thing you could observe is, as the number of levels of page table have increased with all the other parameters being the same, right, then you can see that the effective memory access time is going to increase. It is obviously true, isn't it? If I have more number of page tables, more levels of page tables, then the effective memory access time has to increase, right? And now compare this one and this one. These two data are almost similar, right? Now the effective memory access time is decreasing, and therefore the hit rate also should be decreasing, isn't it? Hit rate should be increasing. So when the hit rate increases, then the effective memory access time decreases. I think you are following it. What I mean to say is, when you increase the hit rate, then the effective memory access time will automatically decrease. So if you have lots of times, if you have the required information in the TLB, then the time taken to on average, the time taken is going to decrease, isn't it? Fine. And next one is, see, let us say there is a memory access time is given, and then the hit rate is given, and the number of levels is given, and this one is given. We are supposed to guess the TLB access time. So how can we guess it? So again the same thing. Effective memory access time is given as 160, and now even the hit rate is given. Hit rate is 0.6, right? And then we don't know what is the TLB access time, but we know what is the memory access time. Similarly, plus 0.4 into, which is miss rate. If it is a miss, we have to find out that is a miss in the TLB, and then we have to go into the main memory and get the page table entry, and then get into the main memory, right? Then what is this going to be? So now if you solve it for T, the value of T is going to be 20 nanoseconds, right? Again you can observe it, as the effective memory time has increased, right, the hit rate is going to decrease. So if the hit rate decreases, then the effective memory access time increases. Maybe some kind of questions are also possible in this pattern like this. If the effective memory access time is increased by so and so %, then what will be the change in hit rate? They'll ask you such kind of questions. That is just simply reasoning kind of questions, aptitude kind of question, which means if the effective memory access time is increased by, let us say, some percent here, and what is the change in the hit rate, right? Something like this. That kind of questions are possible. So now you can solve it. Then what is it? Yeah, so you got 20 nanoseconds, and the next question is, everything is given, but then this is what should be the memory access time, so that the effective memory access time is 170. So again you can write the same thing, right? So 170 equal to, how much is the hit rate? 0.5 into the TLB access time is 20, and main memory access time we don't know, so I am writing it as M, plus 0.5 into TLB access time is 20, plus main memory access time I don't know, therefore I am writing it as 2 into M, Now you can substitute it and you can find it out. It is going to be 100 nanoseconds, right? So everything I did under the assumption that there are no page faults. Next we shall see what is a page fault, and we shall try to combine this TLB with page fault and see some questions.